dispersion. And the key among these measures will be, or let me say, with the measures of dispersion, we are looking at how spread a given data is, or the distribution of a data is, okay? Sometimes you want to look at the dispersion from the central value, which is the mean, okay? Or sometimes we are interested in looking at the dispersion from the minimum to the maximum, okay? Or sometimes dispersion in the center half of the data, okay? And some commonly used measures of dispersions are the range, the coefficient, the standard deviation, and the variance, which are very related, the coefficient of variation, and then the interquartile range. Okay, good. I'm sure for interquartile range, we've looked at it. Okay, we looked at it in our previous class. Okay, after finding the quartiles, that's the first quartile, second quartile, and third quartile. Yeah, so to begin, I think I'll start with interquartile range briefly. Then we'll look at the range, the standard deviation, and the coefficient of variation. Okay. Now for interquartile range, like we said the other day, okay, the interquartile range, usually written as IQR, is just the difference between the third quartile we calculated during the last tutorial minus the first quartile. Okay, that gives us the interquartile range. And as we know, the quartiles partition our distribution into what? 4 equal parts. So if we have this point, that's Q1, first quartile, second quartile, and the third quartile. Okay. Yeah, so this is the first 25% of the data, the next 25% of the data, next 25% of the data, and the final 25% of the data. Okay. And we said that Q2 is the median. Why? Because it partitioned the data into what? 2 equal halves. That's 50% lower than the median and 50% above the median. Okay, now what the interquartile range does is it gives you a measure of dispersion of the central 50%, okay, of the central 50% of the distribution. Okay, so when you find your upper quartile and your lower quartile, your first quartile, you find the difference, okay, then that measure accounts for 50% of variation in the center half of the data. Okay, that is what the interquartile range is used for. Okay, and these ones are usually we make use of them in the plot of box plots. Okay, in the box plots of box plots. Okay, you have your interquartile range, and then even looking for your whiskers and your outliers. Okay, depend on the interquartile range when plotting for the box plots of your data or your distribution. Okay, then I believe we all know by now, we've all mastered how to find Q3 and Q1. If you are still not comfortable with that, just go back to the posted video on YouTube okay, on measures of central tendency, okay? We have a lot of examples there. Okay, next, we want to move on to the range. Now, the range, on the other hand, gives us the dispersion, okay, within the entire data, okay, and it's calculated using what? The maximum observation minus the minimum observation. Okay, so if we have data like 76, 25, 54, 80, 83, then our range will be calculated as what? The maximum minus the minimum, which will be 83 minus 25, which is what? Which is going to be 50 what? 58. Okay, good. So what this is telling us is just like this time around, you have your maximum observation here, okay, and then the minimum is the least. So once you find the range gives us a measure of spread of the data. Okay, it gives us a measure of spread of the entire data set. Okay, so the range tells us the measure of spread of the entire data set. Okay, the next measure of variation, which is a very, or let me say, a very common, okay, measure of variation for us as scientists, are the measures of uh, variance and for standard deviation. Okay, good. Now we're saying that the variance measures, okay, variance just measures the distribution of observations around their mean, okay, and hence the shape of a distribution word curve, okay. Small values of variation means that the distribution curve is more pointed and larger, and the larger value of variance indicates the distribution curve is more what, flat. And I think we've talked about the range, which tells us the coverage of the distribution already. So let's move on. Okay, so this is what we wanted to talk about. The variance, denoted as sigma square, okay, that is the notation, is defined as the average of the squared distance, okay, of each observation from the mean. So we are saying that if this is the observation, the data, okay, and you find the distance of the data from the mean and square it, okay, if you find summation of a quantity over n is the mean, okay, so variance is the average squared distance or the average squared deviate, okay, of the observation from the mean over n, okay, which gives us, yeah, the average, okay, good. So that is sigma. Now, this sigma, as we see, okay, is the sigma for population data. So we are dealing with population data. For population data, okay. Later, when we come to sampling distribution, I'll show you a slightly different formula, which is a standard deviation for sample data. Okay, S squared. Now, like we explained, if we have two distributions, the one with the larger variance is more spread, okay, and its frequency curve is more flat. So when you plot the curve of the distribution, you expect a flatter bell shape, okay, for such a distribution. Now, variance is always positive, okay? The standard deviation is obtained by taking the square root of what? The variance. So the standard deviation is sigma, and is found by just finding the square root of sigma squared. Okay, let's proceed. So in summary, we are saying that to obtain the standard deviation, you find the square root of the variance, and the formula for that is indicated here, okay, as the square root of what? Summation si minus mu all squared over n. I'm sure you've taken note of the formula. Okay, now let's proceed. So stepwise, okay, computation of your variance or your standard deviation is as follows. This is just a summary. First, you will find the population mean, which is mu. Okay, we did that in the previous tutorial. And then you obtain what? The deviation from the mean, which is xi minus mu. Okay, for each observation. Then after which you find the square of the deviations. Step 4, you sum the square deviations and divide by n. Okay, and once you are done, this is the variance. Okay, so if you want the standard deviation, you find the square roots. Okay, you put the square root sign to it, and which means that this square will go off to give you the standard deviation. So you take note of these steps. Now let's proceed. So as an example, we have to obtain the standard deviation for this ungrouped data. Okay, so first step, you have to rewrite your observations. We have 5 observations, 20, 30, 40, 50, 60. So like we said, step 1 is to obtain the mean of the data. So you find the mean of the data, which is what? 20 plus 30. Okay, 20 plus 30 plus 40 plus 50 plus 60 over what? 5. Okay, and when you do this summation, you get 200. Okay, this will give you 200 over 5.
That gives us 40.
Which is equal to 40. Thank you. Good. So this is the mean here. Okay, it's calculated here. Then next, we said we have to find the deviation from the mean. So the deviation from the mean means you have to subtract from each observation the mean, okay? So this will be 20 minus 40. Okay, 20 minus 40 will give you negative 20. Then you do the same here, 30 minus 40 will give us negative 10. 40 minus 40 will be 0. 50 minus 40 is 10. 60 minus 40 is 20. Then next, you have to find the square of the deviation. So negative 20 square will give us 400. Negative 10 square is 100. 0 square is 0. 10 squared is 100. And 20 squared is 400. And then if we should add this is 500. This is 500. So adding the two will give us what? 1,000. Okay. So this sum here is the formula summation x minus mu square. Okay. That is the summation we have here, which is what? 1,000. So 1,000. Good. So to obtain the standard deviation, we said first you find the variance, okay? So divided by n. So our n here is 5. Okay, so we divide by 5. That will give us what? 200. Okay, so 1,000 over 5 will be 200. So that gives us what? The variance. Okay, good. Which means if we are looking for the standard deviation, then all we do is to find the square root of the variance, which is square root of what? 200. Square root of 200, what do you get? What do we get for square root of 200? Yes, square root of 200, what do we have? So we have 14.14, okay, for the variance, okay? So for the standard deviation, sorry. So our variance is 200 and our standard deviation is 14.14. So these are the steps for finding the standard deviation and the variance from ungrouped data. Very simple. Okay. Now, we're going to look at an alternative formula, okay, which will give you the same results. And then after that, we look at the computation for group data as well. So alternatively, we could find the standard deviation using this formula, which is summation x I squared over n minus summation xi over n all squared. Okay, then you find the square root. That will give you the standard deviation. Okay, now what of group data? In group data, as you are aware, the data has already been categorized, and you first of all need to find your midpoint. So anytime you are dealing with group data, your x will be your midpoint, okay? Whilst your f is your frequency. So the formula for finding the standard deviation, or if you like the variance, is what? Summation of the frequency times what? X squared. It means you have to find x squared, okay? Then you multiply with f, and then when you are done, you sum all those quantities, f times x squared. Then this side too, you're going to multiply x, which is the midpoint, with the frequency, and then you sum all those quantities up. Divide by n before you come and square. So this square affects just this bracket, okay? The square is for this bracket alone, okay? So you take note of that. Very well. Now let's look at an example. So as you're aware, in group data, you always be given the class, limit, and you'll be given the frequency. So the first thing you do is to find the midpoint, okay, which we know how to do. It's just add this to this. That will be 33 plus 43 plus 43 over 2, okay? So you do that for all the various classes. You find the midpoint for all of them, and you get this data here. Okay, so the midpoint is your x, okay? So in the original formula, we said you have to find summation f times x squared. Okay, you need to find f times x squared. And you also need to find f times x, okay, times x. So first we have the header fx, okay, and then fx squared. So let's do that for fx first. Fs means you multiply x with f with x. So that will be 2 times 38.5, which will be equal to 77. Then in the next row, it will be 48.5. Okay, 48.5 times the 5 here, okay, which will be 242.5. Then this will be 12 times what? 58.5, which is 702. Then you do same, okay? The last one will be 98.1 times 98.5, which gives you 98.5. Good. So after you are done, you are required to find the summation fx. So summation fx means you're going to sum all these quantities you found, okay? So you are going to sum everything. This will be summation fx. So summation fx is equals to 3315. Then once we are done with this computation, we move to the next quantity, which is summation fx squared, okay, fx squared. Fx squared means we'll have to find x squared first, okay? You have to square all the x values first, okay? So you find the square. So first you have to do this computation. That is 38.5 square. So you have to do that for me. 38.5 square. What did you get?
11482.
Good. Then you multiply with the frequency. So after you square, multiply with the frequency 2 here. What are you getting?
2964.5.
Good. So you do that for the next step too. 48.5 square times 5. Yeah, what did you get?
11,761.
What are you getting?
11761.
Hello, class?
I didn't hear I said.
Yeah, so what did you get? 48.5 square
1171.25.
25. Okay. So these are the values you get when you do the products, the multiplications. Okay. Okay, then after you are done, you
Okay.
sum them. So this quantity will give a summation f x squared. Okay. Okay. So this is what we get for the two quantities. Then you will have to substitute it into the formula. Okay. So we substitute into the formula, and take note again. This is f times x squared. It's different from f times x over n all squared. Okay. So when you go back a bit, you see summation fx is 3315. And then summation fs squared is 227242.5. So when you come here, summation fx is what you have up here. And then summation f times x is what you have here. Okay. And then your n, as you are aware, is the frequency, the total frequency, which is what? 50. Okay. So you put that in the formula. So like I said, this square affects just this quantity. Okay. The square here affects just this bracket, the quantity in the bracket here. Okay. So when you do the computation and you find the square root of it, you should get 12.1, 12.21. Okay, and since we are dealing with books, this can be approximated to 12 books. Okay, and then if you want the variance, okay, the variance is the quantity in bracket here before you squared the value. Okay, that will be the quantity under the square root sign. Okay, before you found the square root. That is the variance of the distribution. Any question? Any question? Okay. It appears we are all okay. Now let's move on to the next concept. So that is for the standard deviation and the variance of the distribution. Okay, so we have an example here. We are to find the standard deviation for the given observations. Okay, can you try that quickly for me? You are to find the standard deviation for the given observations. Can we try it? A class exercise for some mark. So give it a try.
Sir, right now.
Yes, right now. Okay, what did we get? Has anybody finished? Yeah. So these are the steps. As you are aware, I'm taking back my marks. So we are to find the standard deviation and variance. What you do first is to find the mean. Okay. So you find the mean, you add everything and divide by the number of observations. Then after that, you find the difference from the mean. So you subtract the mean from each observations like you have here. 3.5 minus 4.99, that's the mean. Okay, then after which you find the square of it. Okay, then the next thing is you have to find, after you finish everything, you find a summation of the square deviate. Okay, the square deviation from the mean. Okay, and then you divide by the number of observation, which is 7, to give us what? To give us the variance. But to get the standard deviation, you find the square root of it. Okay, so to have the standard deviation, you find the square root. Okay, the square root of the variance. Okay. Yeah, so that is how you go about it. I'm sure you tried, but you couldn't finish. Okay, so that is for the variance and the standard deviation. Now, let's also look at another measure of deviation, which is the coefficient of variation. And when we finish, we try some examples. So the coefficient of variation, or what we refer to as a relative, okay, standard deviation, is simply the standard deviation expressed as a percentage of the mean, okay? The standard deviation expressed as a percentage of the mean. So all you need to do is to first find the mean of the data, find the standard deviation, and when you are done, you divide the standard deviation by the mean and multiply by 100%, okay? It's as simple as that. Okay, now we are saying that the coefficient of variation is not affected by multiplicative changes in scale, okay? And it's a useful way of comparing dispersion of variables measured on different scales. Okay, so let's try to understand these two, and as well as the calculation of the coefficient of variation. We'll go back briefly. So in this example here, our mean was, let me bring down the mean, that was 200, and the standard deviation was 14.1. So we have the mean of the distribution was 200, and the standard deviation we found was 14.1. So to find the coefficient of variation, it's just a relative standard deviation to the mean. So 14.1 over 200 times 100%. Okay, can you find that for me? What did you get?
Sir, it's 7.05.
7.05. Okay, thank you. So we have 7.05%. Okay, so that is how you find the coefficient of variation. It's nothing difficult. Okay, as long as you know how to find your mean and the standard deviation. Okay, now let's look at how this measure of variation is employed. Okay, how it is used. Okay, now assuming I've given you two data sets, I have two data sets. The first data set is length in meters, and the other data set is weight or mass. Okay, let's say mass. Okay, mass in grams. Okay, then for the length I have 2.1, I have 3.0, 2.6. Then when we get to the mass, we have mass of let's say 10.3, 12.2, and then 14.1. And I asked you to, in the question I asked you, to compare the variation. Okay, so compare variation in the data. Okay, good. So we have to compare variation in the data. Now, the clue here is you cannot compare variation in length with variation in mass. They are two different quantities and two different, units of measures altogether. Okay, so how can you be comparing length with mass? It's not possible. But that will only be possible if we can convert this into the same unit, okay, to have the same units. And the only way to achieve that is by finding the coefficient of variation for each data. Now, the coefficient of variation, like we said, is the standard deviation over the mean. The standard, let's take for length. The standard deviation of the data for length will be in meters. And the standard deviation for the mean will also be in meters because it is length. Okay? Now, if we divide the two units, it means that the CV will be unitless. Okay? So has no units. It has no units. The same way, if you find the coefficient of variation for mass, it will also be what? This over mu, which will be in grams over grams. Hence, at the end of the day, the coefficient of variation will also have no units. Okay? So then if both quantities, which is the coefficient for the length and the coefficient for mass, are unitless, then we can have a basis to compare them, okay? Because they are unitless, so they are in the same scale, or let me say the same dimension now. So what do you do in comparing the variability is to find the coefficient of variation, like I've just said, for both data sets. Okay, and in doing that, you first find the mean. So please copy the data down and then find the mean and the standard deviation for me. Be quick with that. So find the mean and the standard deviation. The screen will be off soon, so I'll have to log back in. That's why I'm saying copy the data and find it for me. So this 2.1, 3.0, 2.6. And then for the mass, we have 10.3, 12.2, and then 14.1. Okay. So over here, for the length, if we want the mean for the first data, that will be 2.1 plus 3